So it's taken me a while. Texas Danny Fur asked me to look into Florentine perspective as relation to the Renaissance artwork. So this one was a tough one, Texas Danny. So I would get up every morning and do a search, different search term every morning, click on a couple of things and do a little bit of reading, but hadn't quite found yet what I wanted to find until yesterday. So, just a fair warning, this is a web page. We're talking about Florentine perspective. Now this is we'll go a little bit down. Yeah, we're going to look at this geometry. Okay. So yes, this is a Masonic page intended for teaching some sort of Masonic rank of constable, apparently. So this one might be a little bit long, but I want to get these thought forms out there. So I'm just going to read. Now I'm not going to do a lot of commenting. I'm struggling still to really understand this, but I think, you know, we all, if we all take information, you know, we're all going to have a piece of understanding or a perspective of it, you know, that will enable us to, you know, if we work together in our group consciousness, we'll understand this. So, and I do think it's important. So, anyway, I don't know. Yeah, I'll read the introduction. When we look with our eyes and not with our mind, we can see that space looks very different from what we think it is. In our space, parallel lines meet at infinity. So that's perspective. And you remember this in elementary school. When you go to draw something, you draw a horizon line. You've got a vanishing point, right? And then everything that you draw, it's going to be aligned to that vanishing point. When you get a little more advanced in your painting or whatever, you're going to have two vanishing points. The other vanishing point is going to reside right behind the eyes of the observer. So on the opposite side of the vanishing point that's on your paper. And then you'll get a realistic looking painting. You're doing 2D into 3D by constructing these imaginary vanishing points. All right. Around 1400, during the Renaissance, painters started to look at space with their own eyes and discovered the rules of perspective drawing. Between 1600 and 1800, perspective theory changed from a theory of art to a theory of mathematics called projective geometry. And the Masons are really into this. It took 400 years before a few mathematicians realized that projective geometry was the foundation of mathematics. And it took another 100 years before projective geometry started to influence physics. Okay, so this is where it all started with the Florentine perspective, the perspective art school. You know, how to make a 2D object appear to be 3D. You know, so that when you perceive it, it looks 3D, right? It's about perception, about changing the perception. Right? So in 1908, Hermann Minkowski discovered that Einstein's theory of special relativity could be analyzed using projective geometry. Minkowski created a 4D space-time metric geometry in which he added one time dimension. So that relates back to the dimensions of time video that I did, and there will probably be more of those. Many experiments now show that 4D space-time is not sufficient to incorporate what time really is. The essence of our universe is movement, expanding space, and movement equals space-time. So these are your 3D shapes in space. When you add movement, which necessitates time, or the other way around, could look at the other way around, you're moving into 4D. All right. Both time and space are three-dimensional and represent a different, reciprocal, complementary, or dual view on movement. We can move independently in time or space, and in time and space, the chronotope. The future is expanding space with infinite potential. Time moves behind space and scales space. Right? It moves behind space and scales space as relates to movement. About perspective drawing. A mathematical theory of perspective drawing could only be developed when the Renaissance freed painters to depict nature in a way closer to what they observed. In the Middle Ages, social status was very important. Important people or buildings were always emphasized. Yeah, important Illuminati people or important Catholic buildings. All right, fine, I won't interject. In the Renaissance, the artists started to look with their own eyes and created pictures where the viewer looked through the eyes of the painter. So this is your second vanishing point, which is behind the eyes of the painter. The Florentine architect I didn't look these up to see how to pronounce them, and I should have done that. Filippo Brunelleschi. That's fun, listening to me figure that out. Studied Greek geometry, developed a theory of perspective, and undertook painting just to apply his geometry. The first treatise, Della Pittura, 1435, by Alberti, furnished most of the rules. Alberti regarded mathematics as the common ground of art and the sciences. To make clear my exposition in writing this brief commentary on painting, Alberti began his treatise, Della Pittura. I will take first from the mathematicians those things which my subject is concerned. Alberti stressed that all steps of learning should be sought from nature. All steps of learning should be sought from nature. The ultimate aim of an artist is to imitate nature. Alberti did not mean that artists should imitate nature objectively as it is, but the artist should be especially attentive to beauty, for in painting beauty is as pleasing as is necessary. The work of art is, according to Alberti, so constructed that it is impossible to take anything away from it or add anything to it without impairing the beauty of the whole. So this is form, you know, the visual form. Beauty was, for Alberti, the harmony of all parts in relation to one another. And subsequently, this concord is realized in a particular number, proportion, and arrangement demanded by harmony. So that's geometry. Alberti's thoughts on harmony were not new. They could be traced back to Pythagoras, but he set them in a fresh context, which well fit in with the contemporary aesthetic discourse. Right, so this shows a little device that Leonardo da Vinci used to help him draw things in perspective. The interesting thing that I realized about this is it's kind of similar to your eclipse diagram. Interestingly enough. So moving on, one of the earliest artists to produce a book on how to draw in perspective was Albrecht Dürer. Oh, not the German. As well as discussing sorry about that. As well as discussing geometric methods, he also illustrated his book with a set of woodcuts showing practical tools for accurate perspective drawing. Other artists like Leonardo da Vinci developed comparable tools. Projective geometry formalizes one of the central principles of perspective drawing and of human perception. Parallel lines meet at infinity. In Euclidean geometry, constructions are made with ruler, line, and compass, circle. Projective geometry only require a ruler. So projective geometry is your basic geometry. Euclidean would be more advanced. In projective geometry, one never measures anything. Instead, one relates one set of points to another by a line. Alberti was the first to ask what two pictures have in common if two drawing screens are interposed between the viewer and the object. So your viewers here, your screen, your object. What two pictures have in common if two drawing screens are interposed between the viewer and the object is projected onto both, resulting in two different pictures of the same scene? So let that sink in a little bit. The basic idea behind linear perspective is simple. In every painting, an artist creates a floor or area of the painting where the figures and or objects will be placed. So that's your black and white, symbolized by your black and white checkerboard floor. The floor ends at a horizon line. So your checkers, you know, they appear to get smaller and smaller as it gets towards the horizon. According to your perception, the checkers will eventually disappear to that point. The basic idea behind the basic idea behind linear let's see, what did I just do there? Touchpad. Okay, sorry about that. The basic idea behind linear perspective is simple. In every painting, an artist creates a floor or area of the painting where the figures and our objects are placed, right? Sorry, that helps me get back into, because I had to pause. The floor ends at a horizon line, and the horizon line has a vanishing point or point of convergence on it. The artist then draws parallel lines radiating from the vanishing point outward. Images closest to the vanishing point should appear smaller and closer together, and images farthest from the vanishing point should appear larger and farther apart, given the impression of depth and space in the painting. Alright, so here there are some geometry in here that describes it. Boy, yeah. Okay, so these are tough ones, but these are proofs. I'll just scroll through. If you want to look at them, you want to read them over. This is so hard for me to explain, and parts of it I don't understand. But anyway, these proofs above, what they ultimately prove there up to this point is that we have a principle called duality. In 2D projective geometry, connected points and lines are interchangeable, called an incidence. There is a corresponding duality in three-dimensional projective geometry between points and planes. So here we're talking about moving into 4D geometry. Here the line is its own duality because it is determined by either 2 points or 2 planes, right? These are what's called cross ratios. This is the proofs of this. So I'm just reading the the proof summary, the summary of the proof. I can't remember what you call it. Just reading the end of the proof for you. So what we have here, then what they're showing here, something called a cross ratio. So you have your vanishing point and you have your lines, whatever they may be, going to the vanishing point, and then whatever lines are crossing, these proportions are always going to be the same and predictable. The proportions to each other. So that's a cross ratio. That's the cross proportions that can always be determined. So if the 4 points of the cross ratio are on a line or a circle, then the cross ratio is a real number. Otherwise, the cross ratio is a complex number. Could be infinite number. Okay, so let's see here. All right, so moving into 4D. Although lines in the projective plane meet in one point of infinity, Klein, this one's wrote this last proof, argued that there could be 2 points of infinity if the projective plane was a surface closed in on itself. So this gets into more closer to the shape of the Earth. Also, I believe this ties into that. Although lines in the projective plane meet in one point of infinity, right? Klein argued that there could be 2 points of infinity if the projective plane was a surface closed in on itself. When we look at the origin of projective geometry, the artist painting a sphere, Earth, on a flat surface, it is not difficult to realize that this closed surface is a sphere. Geometry is now divided into 4 layers. Each layer adds a set of assumptions that create certain invariants for that layer. Okay, so 1D into 2D into 3D into 4D. An invariant is a property of configuration of geometric entities that is not altered by any transformation belonging to the specific layer. So I suspect this relates to the fixed events in time that I talked about with the Benedante video, being that some events throughout all dimensions are fixed and some are variant. A transformation is an operation applied to a geometric entity. So you're applying a mathematical operation to it. And if you do that, then you're transforming it. The most common transformations are translation, rotation, and their combinations, reflection. What we will see is that the 4 points of the cross ratio are highly related to the 4 layers. In every higher layer, 1 point of the cross ratio is moved to the internal landscape, the mind, of the observer. This principle is called as within, so without. The first and most, they're literally saying that these mathematics are contained within your brain, this geometry, right? The first and most fundamental layer is the layer of projective geometry. This is the layer of human perception, and it is invariant under the cross ratio. So the human perception fits in with this cross ratio, 2D to 3D to 4D. The cross ratio is what we are perceiving, the proportions of things, right? This is the layer of human perception and is invariant under the cross ratio, also called a Mobius transformation. So I had to puzzle over this for a little bit. Still puzzling over it. I might take up geometry again. It's been so long. Very good for the mind. The second layer is called affine. I'm not sure if I'm pronouncing that correctly. geometry. In this layer, parallel lines are preserved, and the assumption of a plane at infinity, the horizon, is created. This plane generates parallel and orthogonal relationships between geometric entities by placing one of the 4 points of the cross ratio in the plane at infinity. Whew! Yeah, so I'm still puzzling over this and this. But we'll just move on. Affine geometry is Euclidean geometry with congruence. Something is the same when shape and size are the same. That's congruence. Or mirroring. And a metric, a definition of a distance, left out. So we have congruence, but we have no metric. An affine transformation preserves straight lines and ratios of distances between points lying on a straight line. This is the layer of the emotions, the harmony of all parts in affinity to one another, of Alberti. In affine geometry, the frame of reference of the painter, the floor, is created. On this floor, the horizon, the plane at infinity, is drawn. From the point of view of the observer, it is not possible to judge distance or the sameness because a given visual object may be large and far away or small and close. So your perception of distance is subjective. It's subjective. The third layer, metric geometry, adds the concept of distance to the affine layer. A distance is a relation between 2 points of the cross ratio. This is the layer of the painter, the creator, the observer, who creates his own distance to the distances he is painting in the external frame he is looking at. Since projective space is the space of actual perception, the true function of metric space is the coordination of various perspectives. So you could say here threads of fate, right? Because we have many observers, Since projective space is the space of actual perception, the true function of metric space is the coordination of various perspectives. This is illustrated in perspective drawing, in which there are always 2 perspectives being coordinated, the vanishing point and a point just behind the eyes of the observer. So in reality, you have these 2 perspective points, right? that you individually are working with. Okay, so we'll move into 4D here. This is hard for me to understand, but I think this is really important. Just take it in. Just take it in. You don't have to get it. You don't have to get everything. If you go to study something and you don't totally understand it, that's okay. It's okay. Your brain is an amazing thing, and sometimes understanding will come even if you don't believe that it will. The last 4th layer is the layer of Euclidean geometry. In Euclidean geometry, distance is fixed, not relative, and scaled to a unity, meters. This leaves us with just 1 point of the cross ratio, the unity, the 1. Between 1926 and his death in 1983, Alfred Tarski worked on the, that's a tough one, axiomatization of Euclidean geometry. Man! All right. In Tarski's system, there is only one type of object, the 1, the point. All right. There are just 2 geometrical notions between points. The ternary relation of in-betweenness and the quaternary relation of equidistance or congruence. Betweenness captures the affine aspect of Euclidean geometry, equidistance and congruence, its metric aspect. Not sure what they mean there. I don't know if that's just a poorly written sentence or what. All right, moving on. This is the layer of human expectation who has not distanced itself and is looking outside through a small hole at the future. The expectation considers the future as an extension of the past. It's the observer principle. This is how you can manifest. This is how things in the past can be affected by your expectation of the future. In Euclidean geometry, we have to move outside to the objects to measure their distance and the sameness with a predefined unity. If we don't move to the object, we will measure an illusion. Now, I believe this may refer to something that I'm thinking in my mind of as competing observers as we move toward the source and the one. Threads of fate, tangling and untangling. All right, the ancient Sumerians knew that the length of one side of a hexagon is the same length as is the radius of the circle that circumscribes this hexagon. That's not terribly important. So I don't know that I was going to go. Yeah, I was. I was going to go there. All right. So the ancient Sumerians knew that the length of one side of a hexagon is the same length as is the radius of the circle that circumscribes the hexagon. They also knew that the stars of the constellations of the zodiac shift counterclockwise at the rate of 72 degrees per year, 72 years per degree, because of the precession of the Earth's axis. One wobble takes 25,920. Nope, it's 25.920 years. So, I don't know. Do you guys want all these numbers? The length of one side of the Earth hexagon is therefore the distance traveled by the constellations of the zodiac along the horizon. They then subdivided this distance, blah, 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 and that's how they measured time with the constellations. And it says right here, at that time, space was measured by time. So humans at that time measured space by the movement of the constellations, movement by time. The physical space of the megalith was destroyed by the Great Flood, but the metric system survived thousands of years until the French Revolution. On the 8th of May, that's my sister's birthday. Let's see. Anyway, on the 8th of May, there was a proposed change to the decimal system. The Academy of Science recommended that the new definition for a meter be equal to 1/10,000,000th of the distance between the North Pole and the equator, and this was accepted by the National Assembly. Here's how that's important. From that time on, space was measured by space, right? Why the future contains infinite possibilities. Here's the Mandela yellow sun, guys. Look at that. Definitely yellow. Yellow clouds, yellow cloud beams, yellow reflection on the ocean. A painter or a human always looks forward in space. If there are parallel lines visible, they all converge to a vanishing point at the horizon. The horizon is a parallel line at infinity. We all know that the parallel line of the horizon is caused by the fact that the Earth is a moving sphere. This moving sphere moves around other spheres that moves around other spheres. The rotation of the spheres in space is used as a clock. Every time when the cycle of the spheres spheres repeats itself, we add 1 unit to a standard time measure. 1 sun cycle is named a year. 1 cycle of the precession takes 25,920 years, which we have reached the end of in 2012, right? So the interesting thing here that I just want to add, and this is why I keep saying that I think the Earth is smaller if time is faster. You know, the watches and clocks are set different. I got a really cool watch, by the way. It's awesome. Really nice wind-up watch. You can see the glass. You can see through the workings through the glass. It's really cool. So we don't live in the sphere, but we live and move on the surface of a moving sphere. That is why our geometry is an elliptic geometry or projective geometry. Euclides and Pythagoras were aware of projective geometry, but the scientists of the Enlightenment started to interpret their theory with a different eye. They saw numbers in a completely different way the Greek did. The Enlightenment's people, they saw numbers in a completely different way. So they changed the thinking here at this point. The scientists disconnected number from magnitude form and created an abstract static number theory and an abstract static theory of physics. The movement of our universe, the ether, came to a stillstand. Interesting choice of words. The theory of perspective drawing based on our real perception of reality is the same theory that generated projective geometry. We are now back to normal again. All right, in the blog about geometric algebra, I wrote about a very independent thinker called Dewey B. Larson. I'm not interested in these people, but he reinvented physics and projective geometry in his own way, calculated all the well-known physical constraints, and based his theory on a simple, well-known assumption that space and time are reciprocal, a ratio of ratios, the cross ratio, because velocity equals d space divided by dt, time, space divided by time. Velocity equals space divided by time. So what Larson, where is it? Movement is the essence of our reality. What Larson calls motion is the ether wind, or the Higgs field, the velocity which was measured in the north-south direction by this guy named Miller. All right. Motion is the ether wind or the Higgs field, and also velocity, of which formula it would be space divided by time. Einstein believed that the results of the Michelson-Morley experiments in 1887 that proved that the moving ether was non-existent. So the Higgs field, so it is kind of a little bit easier to think of it as a moving ether, which affects material space. Now we know that the experiments were wrong. Einstein also did not believe that space was expanding. That's new to me because I really thought that he did believe that, but I don't know. At this moment, the expanding universe is confirmed by many observations. Right? I don't know. Do we want to get into expanding universe? Yes, because it relates to motion. Okay, when space expands, time compresses. Time compresses and fills up the space to keep balance. Time scales space. Space moves to infinity. Time, or the one. Time moves to the inverse of infinity, 0. Right? Your two perspectives, your infinity point, your perspective of your infinity point. Forward. You have also your perspective of your 0 point. Your 0 point is where you are. That's behind your eyes. Space is measured by the linear, visible, scalar number system. Time is measured with the rotational, invisible, imaginary number system. Expanding space is linear motion. Time is the spiraling motion of the vortex. But that's cool. Space is yang and time is yin. Yin is feminine, curved, rotational, smooth, or cold. Yang is masculine, straight, linear, rough, or hot. Space and time are complementary duals that move around the void. If we look at the human perspective, we are now able to understand what time and space really are. When we look forward, we experience space. Time is always behind our back. Human senses and conventional scientific equipment can only look forward and therefore measure space and distance and the change of space, velocity, and acceleration. I'll repeat that. Human senses and conventional scientific equipment can only look forward and therefore measure space and the change of space. This is a limitation of our physical sensory system, which evolved to measure space, scaled by time, to produce what we perceive as causality, a linear ordering of events. Without the cause and effect system, the sensory world of space would just become chaos. Cause and effect, that's the observer system. Time, history, is always behind us, and space, the future, the adjacent possible with infinite possibility, is always in front of us. I love you. God bless you. Have a great day, you guys. Everything you're doing is perfect. It's perfect. Don't fret. Don't worry. God bless you.